we developed a function, the function to give large positive number among the two numbers. So this is function big AB. It calls on two real numbers and returns a big number. And then we called this function in a vector function, maximum of a vector x whose length is n. So here are the definitions, and it calls on the real big for the function. Okay, and then in a loop structure, we computed that one, the largest positive number in the vector, and maximum of a vector was returned with just one call. Today, I would like to add a third member to this library, that is for matrix maximum number. So for that purpose, let's develop a Fortran program. It's a skeleton, the very basic skeleton. Program name big matrix, implicit none, and program big matrix. Right. So I define some integers I, j, k. Then I define a matrix. I define a matrix of real values A, and we have to specify its length. So for the time being, I am going to define a 5 by 5 matrix. And we would like to call functions from the library. So we have one function big and the other function real maximum of vector. These are the functions from CF library. Okay. And then for algorithmic purpose, to get the maximum value from a matrix, I will first store one row or one column of a matrix in a temporary vector. And I will get the maximum value of that vector because I have a function for getting maximum value of the vector. So therefore, I define two vectors. So I say temporary vector, real, temporary vector of length 5, so that it can store at a time 5 elements from a row or from a column of matrix A. And since my matrix has 5 rows and 5 columns, so I will get 5 maximum values. One for first row, one for second row, one for third row. So I have to store those values in another vector of length 5, and then I will get the maximum of the whole. That's my strategy, and that's I'm going to implement right now. So then I define another temporary matrix. So I call it, okay, it's a temporary vector of 5, right? So let's write my purpose here. It is important to store vector to store maximum values. Okay, so I hope I have defined the required things. Now the initialization of values. So I define the matrix A. For the time being, I define it like this. The forward slash, I define simple values 1, 2, 3, 4, 5. And I think that is okay. For the time being, let's keep it simple. 6, 7, 8, 9, 10, 11, 12, 13. Okay. 10 values have been stored. The rest are 15. So I say 15 times 0. Right? So for the time being, I don't know whether these values are stored in row fashion or column fashion, right? So the data is correct, not. Let's print that one. So I write do I equals 1 to 5, and I write do j equals 1 to 5, and I print the values of a. So I write print asterisk a I j and do and do. So to see whether our program is correct to this point or not, and this program must be compiled with the library B77. Okay, big matrix dot for minus o big matrix dot exe has been rightfully compiled. So it is going to print the data values. So big matrix dot exe. So values are printed in a column, right? So we don't recognize that one, how the matrix has been initialized. So 1 6 0 0 2 7 0 0. What has happened? So let's see that correctly. Let's see that correctly. In that case, I write another do structure, which is within the statement of print. And here we go. So I write this loop. This is only used in the reading and print statements 1 to 5. So this is known as the implied loop in matrices. It is implied do loop. Implied loop. So let's compile it and run it again. CLS compile it and run. So 1 2 3 4 5 6 7 8 9 0. So Fortran has assigned the values column wise, right? Column wise. So therefore, it means we have to read the data in a specific fashion. Our statement, our reading with this statement was not appropriate. So we have seen that the Fortran default fashion is to set first values and fill them in the column, then picks the next values and fill the column, and that's it, right? But our objective is different. We would like to call our functions to get the maximum value, maximum positive value. So here we go. My strategy is that I will pick up one row, right? In the row, I will fix the row index and move with the column index, right? And this I have to do for 5 rows, right? So here we go. So I say for 5 rows, so I say I index is for row, I varies from 1 to 5, and I have to set the temporary vector. First row will set the values to the column. J varies from 1 to 5, and I say temporary of j, temp of j, element j is equal to a I j. So interpret this statement that the loop is going to pick one value of I, right? And then it will take on 5 values of j. So it is moving in the first row, and it is setting one by one values to the temporary vector elements, right? So only with this statement, only the j index is changing. So 5 values will be stored to the j in the temporary vector. So one vector is created. What we have to do after this vector creation? fill the temporary vector. So vector is there, and we can now call the vector function. Now here, get the maximum value of vector. So I can write maximum vector, which is the function of temp and 5. So first row stored in the temporary vector is now we are looking the maximum value into it, right? So this maximum value should be stored. This is the maximum value of in the ith row. So I store it in the temporary vector of I, the first entry. So ith row, fill the ith row of A to the temporary vector, and then from that vector, get the maximum value and store it in another place. That's it. That's it. And then this is the end do statement. So that we have to do for all the rows, right? And after this process, we will have the maximum values of rows in the temporary vector TMPV. And then the maximum of this matrix, will be equal to maximum of rows have been set into temporary vector. These are maximum of each row, maximum of the ith row. But with the programming, you have to do the imagination, how you are moving into the matrix. So maximum of matrix will be then equal to, again, we will call maximum of vector. Now we will say temp V, whose length is 5. So at this point, I realized that maximum of mat has not been defined. So I define this one as before the data statement you can define, because data statement is an initialization of data. So it's like saying A is equal to 1, 2, or whatever values are assigned in the data statement. So I define here a real value maximum matrix. Okay. So the maximum of matrix has been computed, and then we can write it, the print statement, print asterisk. Okay, maximum of matrix A is equal to maximum of matrix variable. Right. So in this program, I have given a call to several calls to maximum of a vector, and we know the maximum of a vector in itself calls the function big AB. So now it requires a compilation with the library, because in those statements we use the library. Therefore, we call cf library dot for big matrix dot exe. First step. Wow, the pendulum is very fast. Big matrix dot exe. What maximum we are expecting? It will print the matrix and the maximum value. Maximum value. Amazing. Let's move forward to develop the function for it, and yes, this was the algorithmic part, where we call upon the once the data values of A are known, then we work with the temporary vectors, and finally the matrix maximum value is returned. That's the part of the algorithm we have to copy. So I first copy it and paste it just below the program. Uh, Big matrix. This is the end program, and okay. So below this one, I am filling the part. Let's define the variables in generic way. From the seventh column, I write function maximum of matrix. It should call a matrix, square matrix for the time being. So we have to have integer n, and we must have real a n by n. And what we require 10 of n, meaning real, and we require real m v of n. We used integers I, j, I, j. And this function should call the function maximum of vector, and it should in turn call the function big from the main library. And this is the part of calculations. Let's see whether it is consistent or not. Do I varies from 1 to n. So make it generic. 1 to n. Ij. And maximum of this one for n. Do. And well, after that, uh, one statement is missing from this one. Okay, yes. Maximum of matrix. After that, maximum from the final vector, then return statement, and the end function, maximum of matrix. That's it. So that is the function style. And let's see how it will work. Real maximum of matrix. Now it is not the variable, now it is the function, which is for the time being within this program. But I have to call the maximum of matrix by the matrix name and its size, right? So let's test it with the function call. Program should be compiled with the library. Wow. And then the results. Oh, -1 number. Something is inconsistent. Number has not been returned, so there is numerical error. I defined real maximum of vector mv maximum of matrix A. Okay, there must be some initialization for something. A is there. Do I, do J, temp B. Maximum of matrix written MB. The 5. Oh, okay. Yes, this is 5. This should be n. Right. So with the error, we relate it to something tangible, in computing. to calculation, right? So again, compile. Okay, it is the saving problem. CF library. Yes, we have to closely see A5. Yes, here it should be 5. And finally, it should be, well, these are not required. These are not required. Real matrix. Maximum of a matrix. Maximum of matrix. temv and temv return. Save and CF library. Maximum of a vector. Undefined reference to maximum of a vector. Maximum of a vector. Maximum of a vector. Maximum of vector is there. Undefined reference to maximum of a vector. Maximum of a vector. No guess. We require tangible. Oh, library. Yes, not this one. Big matrix dot for. Oh yes, it's compiled. The library was not compiled. Pardon. Big matrix dot exe. Again, -1 and ind. So it has been found that maximum of a matrix vector has not been defined variable. So maximum, real maximum of matrix. This was not defined here. That was the error in -1 ind. So not a realistic value was returned for maximum of a matrix. So that's the linkage of the error. It was not defined. CLS. So errors give you an opportunity to learn and explore. Like we say in Urdu, दाग तो अच्छे होते हैं. So let's run it. Enjoy the success. The function has been developed, and now this can be moved to the library. Complete picture has been developed as it was done several decades ago at DAG library development. Function for maximum of matrix based upon maximum of a vector, which is based upon maximum of two numbers. And now it is part of our CF library, which is 100, it has crossed 100 lines. So 100 for CF library. Century of CF library, not the others. That's the nice thing. So big matrix, it requires a saving. And now I give another test. Define another matrix B of length 10 by 10, right? 100 elements, and I initialize it with the random numbers, no problem. And then let's get the maximum of it. So print. So it is the power play started. Power play of matrix library. So define do quickly. Do I varies from 1 to 10, and do j varies from 1 up to 10. So b of ij, b I comma j equals then some quick values. and do, and then, and if we get 100 random values, what will be the maximum? So print maximum of B matrix equals maximum of matrix B whose size is 10 by 10, right? Quick values. और चाहे तो इस and likewise let's print the B entries 1x f 7.4 and dollar sign, and this one B I comma j, and then I know print dash and dollar sign and this one. So I will print and we will see the maximum value in matrix B as well by calling the program, and the program should be compiled with the library. So two maximum values. And here we go. The climax of today's class. The matrix B is printed, the random values, and the maximum value is 0.999. The random numbers are between 0 and 1. So the maximum value, can we quickly figure that out where this 999 is there? So we are looking for that one point. Yes, this is, yes, 0.997 because the format was 7.4. So that's the way to do with the functions and matrices, right? So congratulations that our CF library has exceeded a century.